should know something about internal ear. It consists of what? Labyrinth, yes. And labyrinth of yes, that is the same labyrinth. It is right, and that is the same right labyrinth. How to identify? Is it right or left? Labyrinth consists of cochlea. It is cochlea in front. That is a vestibulum, and it is semicircular canals. Canalis semicircularis anterior, canalis semicircularis posterior, and canalis semicircularis lateralis. That is why if I take in my right hand this canal, it looks laterally. If I take in my left hand, what happens? Now it is medially. It is not correct. It should be laterally. That is why it is right labyrinth. Right labyrinth. The same like here. It is broken canalis semicircularis lateralis, but it is clear that this labyrinth is right. It is vestibule, and you can see that vestibule has two windows. Today we already said that is fenestra vestibule and fenestra cochlea. Fenestra vestibule closed with the base of stapes, and fenestra cochlea with a secondary tympanic membrane. Which receptors of which analyzer in cochlea? Oh, that is organ of Corti. That is receptors of which analyzer? Auditive analyzer. And receptors of which analyzer in vestibule and in semicircular canals? Statokinetic, you're right. That is statokinetic or vestibular analyzer. More better statokinetic analyzer. And today we will speak about two analyzers, auditive analyzer and structure of cochlea, and statokinetic analyzer in semicircular canals and in the vestibule. And this one is bony part of labyrinth. And inside of bone we have membranous labyrinth. For example, in anterior semicircular canal, inside of this canal, we have the same duct, ductus semicircularis anterior. That is membranous labyrinth. It is. In posterior canal, we have the same ductus semicircularis posterior, and it is ductus semicircularis lateralis. Inside of vestibule, we have two structures. Utriculus, it's joined with these semicircular ducts, and sacculus, it's joined with ductus cochlearis, which is inside of cochlea. And between utriculus and sacculus, we have ductus utriculus sacularis, which continues into ductus endolymphaticus and finished in saccus endolymphaticus. And space between bone and membranous labyrinth, that is perilymphatic space, and inside of membranous labyrinth we have endolymphatic space, and perilymph and endolymph. Do you know this fluid outside between bone and membranous labyrinth? We have perilymph, and inside of membranous endolymph. Can you give me a piece of paper or copybook? That is a cochlea. It has how many waves? 2.5, yes, 2.5. And if I draw cochlea like a straight tube, that is a cochlea. Okay, that is a cochlea. And inside of this cochlea, we have ductus cochlearis. That is a ductus cochlearis. In histology, you draw this diagram. That is, if we cut cochlea, we can see that is canal of cochlea, and inside that is ductus cochlearis. And we can see perilymphatic space above of ductus cochlearis, between cochlea and ductus cochlearis. What is this space, number one? What is? Scala. Oh, that is perilymphatic space, but it has specific name. Scala. And it is the same space below of ductus cochlearis. That is another scala. It is scala vestibuli and scala tympani. Almost. Scala vestibuli, this scala vestibuli, it starts from fenestra vestibuli. Here it is fenestra vestibuli. And you already know that fenestra vestibuli closed with a base of stapes. Here it is stapes, and base of the stapes closed this scala vestibuli.